Right, well, hello and welcome to this video. This is, I should put this up there actually, the start of a long line of C2 Edexcel AS videos. Now, we sort of, probably up already, I should know this but never mind, I put a logarithm tutorial up. Now, I did that first. Purely because I thought it was the one that I struggled with the most when I had a quick look through C2. So I think the best thing to do was to put that up if it's up yet, and because that's the first one I did anyway. Anyway, so waffling. What we're going to be doing, C2, is geometric progressions. Now, I just put geometric progressions. You may be going, oh, what is geometric progressions? Well, you know like you had I'm not going to write this down because it's quite easy. You know like your the nth term where you had a number going up by a certain amount, say, you know, plus 2, plus 2, plus 2, and you use like an plus 2 equals 3n plus 2 is the sequence, that's sort of year 7 stuff. Well, this is C2, so we are increasing it by, or increasing or decreasing by a certain factor, a times factor. So if we times it by 2, each one is doubling. So there's a few things we need to get to grips with. Now, the first thing, I'm going to throw a formula straight at, oh wait, actually, I'm going to show you how to create this formula instead of throwing it straight at you actually. So I'll create a standard sequence. So it's going to be going up by 2 each, times by 2, 2, times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128, times 2 is 256, and so on. Now, sorry, we have something called we have something called A, which is our starting sequence. So you just put A as the starting number. Just put starting number. And R is something called the common ratio. That was it. I forgot what the first word was. Right, okay, so that's something called the common ratio. Now the common ratio, as it's assumed, is common. So this basically means, I don't know if you can see this, but 2 to 4 equals R, 4 to 8 equals R, 8 to 16 equals R. Now we're not adding R each time, because if we did that, the difference between these two, 4 and 2 is 2, which is okay, but between 4 and 8 is 4, so it's increasing by 2 each time. The number before, so 2 to 4 is times by 2, 2. So the way to find R is divide the next one number in sequence by the previous number in sequence. So 4 over 2 should be directly equal to 256 over 128, which it is, which gets us 2 equals 2. So that shows us the common ratio is 2. So we know 2. Sorry, I'll get rid of that. Hopefully you're proving not to just by saying it. So the common ratio is 2. Now we know the starting number just by looking at the sequence, and that is 2. Rather confusingly as well, it's also 2. Shouldn't have started like that actually. So if we want to, we've got something called n, which is our desired number in the sequence. Number in the sequence. So I'm just going to prove something to you now. So get rid of these R's. So I just put this over here. A equals 2. R equals 2. So now we've got, we'll start with 2. And now that is the same as 2 to the, sorry, one sec. So 2 is A, so this is the same as writing A times R, so 2 times 2, A times R to the R squared, that's same as AR to the 1, AR to the 2, AR to the 3. Now these correspond with the corresponding one above. So AR is 4, AR squared is 8, AR cubed is 16, and so on. Now I've proved that, so you can see sort of a formula here appearing. Let's just put AR cubed just to make sure it is 16. So 2A, 2 times R squared, which is, sorry, R cubed, which is 2 cubed, so 2 times 2 cubed is equal to 2 times 8, which is 16. Hopefully that's proved it to you. Just make sure you can see that. Yeah, so you can see there, 2 cubed, 8 is 16. So we've proved that to you. Now you may notice each letter here, so the 4 sequence is AR cubed. The second sequence, the third sequence is AR squared, and the first sequence is A. So each number is increasing, sort of, if you have an R on it, the number above the R, or the power of the R, if you add 1 to that, you get the number in the sequence. So if you've got the 5th number in the sequence, it's AR, and N, which is the number in the sequence, take 1. Now I explain it very well. So do it the other way around. If you want the 3rd number in this, if you want the 3rd number in the sequence, you take 1 away from that. So 3rd sequence, 3rd number in the sequence, take away 1 is 2. So it's AR squared. Now that AR could be anything. It could be it could be any starting number. It could be any common ratio, given it's the same. So hopefully that's proved. And now we can use that to come with a formula, which is, I'll put it over here actually, it's quite important, which is, if you want to find a number in a sequence, it's AR n minus 1. I'll prove this to you, if that hasn't already. So we know the, let's do, I don't know, the 1, 2, 3, 4, 5, 6, the 6th number in the sequence, so n equals 6, a equals 2, r equals 2. This hasn't changed. We put this into the formula, ar to the power of n take 1, so 2 times 2, 6 take 1, equals 2 times 2 to the 5, equals 2 times 32, equals 64. Hopefully that's proved it to you. Okay. Hopefully it has. Right. Now if it was going down, if you were asked to check, sometimes it doesn't say if it's a geometric sequence. Now if it's a sequence in the C2 exam, it's going to be geometric. But to make sure it is, you divide one number by the previous and do it for multiple numbers, and they should get you the same sequence, sorry. Yeah, same common ratio. No, yeah. Sometimes, actually, before we go on to the sum, sometimes you may get something like this. So, it doesn't tell you the first sequence, number, doesn't tell you the second, tells you the third. Let's actually use our old friend, the 2468. So we know the thing is 2 times 2 is 4, times 2 is 8, so the third sequence is 8. This is the example that works, so I'm just going through this. That's going to be 16, but we say we're not given that, and this number is going to be 32. Yeah, so we're saying that, and it says, find out the starting number and the common ratio. Well, if we've got, this is, the first number is A, we're not given AR, given AR squared, we're not given AR cubed, we're given AR to the 4, because AR, the power of n take 1, gives us the number in the sequence that we're trying to find. So, we know AR squared equals 8. AR to the 4, sorry, equals 32. Now, how can we get, oh, actually, how is that going to work, is it? Sorry, actually, no. So actually, sorry, give me a minute. That's not going to work because I'll only get R squared. I'll give this a 16. That says find the common ratio and find the starting number as we did before. So we know AR squared, which 2, 4, 6. So 2, 4, 8. 8 is a third number. 16 is the fourth number, so AR cubed equals 16. And it says find the value of oh, actually we could have done the other way around. Sorry, my brain's in a mess. So we know AR cubed equals 16 and AR squared equals 8. So we can divide these. So AR cubed equals 16 over AR squared equals 8. When we divide, the A's cancel out, so we're left with R3, take R2. We take the powers away when dividing, so R to the 1 equals 2. So anything to the power of 1 is itself, so R must be 2. And we know that from doing the thing before. Now if you know R is 2, we can simply put it back in some of these equations. So I think the easiest one to do is AR squared equals 8. So A times R squared, 2 squared, equals 8. So A times 4 equals 8. So A equals 8 over 4, which equals 2. So that's the other way of going round it. I get it out of the way so you can have a look at that. I mean, hopefully it should be quite straightforward, but if it's not, then that should have cleared something up. Okay. Right. Damn it. Sorry, I just this should have been an outtake, really. Mind? Right, there we go. Just making sure my head's not too big when I come to the picture. So I'll get rid of that. Hopefully you've got that down. And get rid of that. These. I just put the thing back, but I'll get rid of the numbers because. Right. So we can work out now. Hopefully, if you've been listening, we can work out what number is in sequence. Obviously, that was going up and multiplying. It could be going down by times by half if you think of it that way. But you might get asked. Sorry, I'm just trying to look for this question. It got me when I first did it. Oh, actually, I think this one's a good one to do here. So it says, it gives you the first 3 terms, as we've done before. So it gives us k take 8 is one number. That's the first. And then the next one is k plus 4. Again, k plus 4 is just one whole number. And it tells us k is an integer. And 3k plus 2, respectively. Now we said, that gives us our number, and it says, where k is a positive constant, find the value of k. So what we've got to do, now we know that the difference between these two, if you divide 3k plus 2 over k plus 4 equals r. So k plus 4 over k take 8 must also equal r if it's a geometric progression sequence, which it tells us in the question. So we're trying to work out r. So we know 3k plus 2, put in brackets because it's one number, over k plus 4 is equal to k plus 4 over k take 8. Now that looks all very fancy. So basically we times each side by the other one. So we times this side by k take 8, we times this side by k plus 4. So let's do that. 3k, I'll just expand it. Well, I won't expand it, sorry. I'll just leave it still in brackets so you know what I've transferred across. K take 8 equals k plus 4 I could put squared under there because it's times it by itself. I'll just put it here, k plus 4. Expand both these brackets so we get 3k squared, take 16, take 2k, should be 16, take 2k, take 24k, equals k squared plus 16 plus 8k. Simplify that down if we can. 3k squared, take 16, take 26k, equals k squared plus 16 plus 8k. Simplify that down, bring all this over here. So 2k squared, is that how I've done it? Oh, sorry, I've done something wrong. Oh yeah, so we plus 2k, sorry. Just going wrong there. Should be plus 2k. So it's minus 22k. 2k squared, take 30k. Take 32 equals 0. That's our equation. See if it's... Yep. So we divide this by 2. 2 equals k squared, take 15. Take 15k, now that's just 30k over 2. Take 16. Now let's see if we can simplify that down. So, sorry, just give me a minute. Sorry about that. So, 2 in brackets k. Now we divided it by 2. So what we can do is see if we can factorise that and see. We can. So, 2 is k, see how I factorise it, sorry, k, take 16 and k plus 1. So as it says, k has to be a positive integer, so if we do that, we get k is equal to be 16, sorry, or k is equal to be minus 1. Now it says k is positive, so k must be 16. That's how we work out k in that situation. Now it does ask for a few other things, which I'll go through. Oh, actually, sorry, this is quite an important one. I'm just gonna get rid of that. Just give me a minute to note that down because it's quite an important one. Right, I'm going to do the sum. I'm going to prove it to you, the sum of the formula. So we talked about AR take 1, that's very nice. But as you probably guessed, the next thing we want to do is find the sum of that. The sum of the terms. You might have done this in sequences and progressions in arithmetic in C1. If you haven't, I'm going to do a video on it, but this is the C2 version. So we're given, as I said, I'm going to prove this to you. So we're given the formula Sn equals A1, sorry, which way, it doesn't matter which way around, I'll explain that in a minute, N take 1 over R take 1. Now, these two can be the other way around on each, but it could be 1 take Rn or R to the power n, or 1 take R, or this way around. It just depends. If your R is bigger than 1, you do that. If it's not, you do it the other way around. I mean, it doesn't matter which way actually, but it just means you won't get confused with negatives and your calculator won't mess it up for you in the exam. So, anyway, it says, prove the sum, the series is given by this, and it says like this, AR squared, AR cubed, etc. And that's we know that already from doing our previous encounters with this kind of stuff. So one sec, let me see how I've done this. Shall I just So we've got our thing here, AR squared, AR cubed. Now we can one sec. One sec, sorry. So we can divide. One sec. So we're going to do Sn equals. So we're starting this, and we should be able to get to this. So Sn equals AR squared, AR cubed, etc. Now if we divide both sides, what was it, by R. If we divide both sides by R, or times, is it times? Times both sides by R. R times Sn equals A. Now this A becomes AR, and AR becomes AR squared. All we're doing is raising the power by 1, by times it by R. So that seems okay. So yeah. Sorry, just trying to work out I've done this. And if we carried on doing this, we'd get Sn take R times Sn. Sorry, this isn't very clear. Don't worry, it isn't all 100% to me. And that gets you A take AR to the N. So basically, we times both sides by R, increase power, and then if we carried on doing this, we'd get that. Basically, it's a simplified version of, because this would carry on. So that's just a basic simplified version. We times R by Sn, and we got these two, and we simplified it down. And if we put this in brackets, what we get is Sn of 1 take R. So, and then we can do the same. We can take an A out both of here. So A 1 take R to the N. You can see it's already starting to look like that now. So we basically turn this into a brackets at the bottom. We turn that into brackets. So we've taken A and we've taken Sn out of here. So we've gone from here, divided by times by R, simplified this down as it carried on, times that out, put it back in brackets, put that in brackets from there, and then we're going to divide both sides by 1 take R, so this just becomes Sn equals A 1 take take R to the N over 1 take R. Now you can switch that round, but that's how you do that. That's all there is to geometric progressions. Really? There is a bit more I just like to go through, but we'll not waste your time and mine. If you do want to see the next bit, and I will be doing another video later on, but that's the main course of geometric progressions that I've done there. So we'll see you in the next video.